Alright, so this is lesson 3.2 in trigonometry for Math 10C. What we're going to do today is we're going to learn how to find missing side lengths on triangles. Now I know, we already know how to do this, but we use something called Pythagorean theorem. And Pythagorean theorem only works in the situation where you know two side lengths and you're looking for the third missing side. Unfortunately, sometimes we don't have two side lengths given to us. We only have one side length given to us and one angle given to us. So when you're given one side and one angle, you need a new strategy to find missing side lengths rather than use Pythagorean theorem. That system that we're going to use is using your trigonomic ratios. Remember, your trigonomic ratios are SOHCAHTOA. These are the ratios we learned in 3.1. Where sine equals opposite divided by hypotenuse. So that's what SO stands for. Sine equals opposite over hypotenuse. Cosine is equal to adjacent divided by hypotenuse. And then tangent is equal to opposite divided by adjacent. So SOHCAHTOA helps us find side lengths when we don't have two side lengths given to us and we only have one and an angle. This page is a little notes page that shows you step by step how to find it. You can come back and refer to this page at any time you want. The step-by-step instructions, we'll go through them right now. So the very first thing you do when you're given a triangle is you need to label your triangle hypotenuse, opposite, adjacent. The opposite is always across from the angle that you're given. The hypotenuse is always the longest side, and the adjacent is always the third side. Once you're given your triangle and you've labeled them properly, I want you to circle the side lengths that you know. So in our case, we're going to circle the adjacent side because we know it's 2.5. And then I want you to circle the side length that you want. We want to figure out what the opposite is because it's the side that was labeled x. And you're always trying to solve for whatever is labeled x. The third step is you have to figure out which of these trigonomic ratios you want to use. So do you want to use sine or cosine or tangent? To determine which one you want to use, you write out the words SOHCAHTOA. And SOHCAHTOA is like a checklist. So it's going to show you which trigonomic ratio you should use. Sine, cos, or tan. And to do that, we have to check some things off. I want you to give a free check mark to the first one of each. So for sine, cos, and tangent, I give it a free check mark. Now, see these two circled sides. Opposite stands for O, right? And adjacent is all of my A's. So anywhere I see an O, I'm going to give a check mark. And anywhere I see an A, I'm going to give a check mark. And you should notice that one of these sayings, SOHCAHTOA, will have 3 check marks. Whichever one has 3 check marks is the one that you want to use. So you want to use your tangent ratio. Your tangent ratio equals opposite over adjacent. Remember, those formulas are given to you a couple slides back at 3.1. Right, it should say 10 bracket theta bracket. That little theta, this thing right here, that means angle. So that's talking about the angle that we're working with. Now, we need to solve for our missing side length. To solve for our missing side length, we take all of our information we know and we change it. So we change the the angle to be 33. We change our opposite side to be x. And we change our adjacent side to be 2.5. So now instead of words and symbols, we have numbers and x. Your last step is to solve this thing. To solve this means to get x by itself. To get x by itself, we need to move this 2.5. So we need to somehow undo a division. To undo division, we multiply 2.5 to both sides. So now you have 2.5 times tangent equals x. So in your calculator, you punch in 2.5 times tangent of 33. And you should get that that thing is equal to 1.6. So x is 1.6. Okay, we're going to do this 3 times together. Then you're going to have some practice. And then we're going to do word problems. So, first step. If you need to label your side lengths. So, opposite is always across from whatever angle we're working with. Hypotenuse is always the longest side, and then adjacent is always your third side. Step 2 was to circle the side length that you know and the side length that you want to know. So we know adjacent is 12 centimeters, and we want to know what the opposite is because it's labeled x. Third step, write out SOHCAHTOA. And check off all the side lengths that you have circled. So anywhere you see an O, you check it. Anywhere you see an A, you check it. And the first letter in each of those, it all gets a check. So the S, the C, and the T are free checks. So in this case, we want to use TOA because it has 3 checks. We set it up, so tan of theta equals opposite over adjacent. That's our formula. Now we change out our symbols and letters for our values. So this becomes tan of 45 equals x divided by 12. To get x by itself, we multiply both sides by 12. So 12 times tan of 45 equals x. We punch that in our calculator, so we go tan 45 times 12, and we get that 12 equals x. So that missing side length was 12 long. Alright, we're going to do this again, so you can get lots of review with it. Your first step to solving a side length on a triangle is to label your triangle properly. The hypotenuse is always across from the 90. Whatever angle you're given directly across, we call it the opposite. Adjacent is always the third side. Next thing we do, we circle the side length we know and the side length we want to know. We then write out SOHCAHTOA. We use SOHCAHTOA as a checklist to try to figure out which ratio we need. We give check marks to the first 3 things. The S, the C, and the T. They all get free ticks. We then tick off any circles we had any sides we had circled, we check off. So we want to check off all of our H's and all of our A's. And when you're done, you should have one thing with 3 check marks. That's the ratio you want to use. CA stands for cos equals adjacent over hypotenuse. So cos of theta, remember that symbol means angle, equals adjacent over hypotenuse. We then fill in anything that's missing. So it's going to be cos of 70, because that's the angle that we're working with, equals the adjacent was x, the hypotenuse was 8.2. Now that we've set it up, we need to try to get x by itself. To get x by itself, we need to multiply that 8.2 to the other side. We have 8.2 times cos of 70 equals x. We punch that thing in our calculator. We go 8.2 times cos of 70. And we have 2.8 equals x. If you've been doing these questions and not getting the same answers as me, make sure your calculator is in degree mode. If you're not sure how to do that, click on mode, look for the word degree, and highlight it, or ask a friend, and they can help you out. All right, one more. Our first step is to label your triangle. You must label it properly. The opposite is always across from the angle that you're working with. The hypotenuse is always across from the 90. And then the third side is always the adjacent. Step 1, label your triangle. We did that. Step 2, circle the side lengths you know and you want. We're going to use those in step 3 to figure out which ratio needs to be used. Sine, cos, or tan. You use this as a checklist where you give a check mark to the S, the C, and the T for free. They all get a free check. And then you check off any of the circled sides you have. So opposite stands for O, and hypotenuse is the H. In this case, so is the only one that has 3 check marks, so that means we need to use the sine ratio. The sine ratio equals opposite over hypotenuse. Now that we've decided what ratio we want to use, we need to replace our symbols and letters with values. So this will become sine of 27 equals, the opposite was 7, the hypotenuse was x. This one is a little bit trickier than the other ones. You notice if you look at the other ones, x was always on the top of our fractions. Now x is on the bottom of our fraction. So that's going to make things a little bit trickier. When x is on the bottom of your fraction, the x and the sine of 27 swap spots. So now x is over here, and it equals 7 divided by sine of 27. So if the x is on the bottom, you'll be doing division. If the x had been on the top, like the last 2 questions, we would have done multiplication. So in this case, we just need to go 7 divided by sine 27, and we find that x equals 15.4. Okay, these next 3 questions, you can do them on your own, so you should pause this video right now and do a little bit of practice. Some hints, this one should become sine. This one over here should become cosine. And this one over here requires you to use tangent. But use the steps to know what things are what, but those are the ratios you should be using. The answers to these are 15.4, 1.3, and 18.9. Again, you should be checking your work, not just copying it down. Part 2 of this question was determine the missing angle in each of the questions above. We talked about this on our first lesson, and we talked about the fact that you can find the third angle by using our 180 trick. All angles in a triangle should add up to be 180. So if you know 2 of your angles, you know this one's 90, you know that this one's 27, then 180 minus 90 minus 27 should tell you the size of the missing angle. And in our case, it's 63 degrees. I want you to practice the other two and see if you can get the answer. The answer is 27 degrees for B. And for C, the answer is 48. So those two you should be trying on your own to see if you can remember that 180 trick. All right, our last question. So trigonometry is not too difficult, but what really seems to make trigonometry more difficult is word problems. This first problem here says solve the triangle. When you see solve the triangle, that means you have to find every missing side and every missing angle. I always start with whatever they've labeled as x, if they've labeled anything. In this case, they've labeled this x. So I'm going to start by trying to find that side length, and then I'm just going to find the rest of the side lengths on my own. So if I want to find a side length, and I only have one side length given to me, and one angle given to me, I need to use SOHCAHTOA. To use SOHCAHTOA, I have to label my triangle properly. This is my hypotenuse, this is my opposite, this is my adjacent. The next thing is to circle the side length you know and the side length you want to know. Then you write out SOHCAHTOA. And you check off the first letter of each. You then also check off the H's because you want to know your hypotenuse. And you check off the A's because you do know your adjacent. So ka is the answer, or the ratio we need to use to find this thing. Ka is cosine of an angle equals adjacent over hypotenuse. We then replace our symbols with numbers. So the angle is 58. Remember that weird little symbol is theta, it means angle. And the angle we're working with is 58. Equals adjacent, which is 9.2, divided by x, which is our hypotenuse. X is on the bottom. Because x is on the bottom, it needs to switch spots with this cos. So x equals 9.2 divided by cos of 58. If you punch it in your calculator, 9.2 divided by cos of 58, you'll find that x equals 17.4. And I'm just going to put that up here so we remember. Great. Now that we have one side, we have to find our third side. To find our third side, we have two options here. We could use SOHCAHTOA because we have a side length and an angle. Or we could use Pythagorean theorem because now we actually know two sides. I'm going to use SOHCAHTOA. The reason we're going to use SOHCAHTOA is because if I had screwed up the first part of the question and I got the hypotenuse wrong, and now I'm using the hypotenuse to try to find the opposite side, if I messed up the hypotenuse, then I'm also going to affect my opposite and mess that up. So I'm going to use SOHCAHTOA one more time. To use SOHCAHTOA again, I'm going to erase my circles. I'm going to relabel everything out. So it's adjacent, it's hypotenuse. But instead of looking for x, which is right here, I'm going to say this is x. And now I need to find that side. So all I've done is relabeled what side I want to find. SOHCAHTOA still works the same. You write it all out. You checklist your first three things. You checklist the side that you want to find and the side that you have given to you. And you notice that I've circled them. So I circled my opposite and my adjacent. Tangent has 3, so we want to use tan of theta equals opposite over adjacent. We now fill out. We fill out the things we know. So instead of theta, we put in the angle of 58. Instead of opposite, we put x. Instead of adjacent, we put 9.2. Because x is on the top, we can get rid of this 9.2 by multiplying both sides by 9.2. So that means 9.2 times 10 of 58 equals x. We punch that in our calculator and we go 9.2 times 10 of 58. 14.7 equals x. So this side is 14.7. Now we're not quite done. We found all the side lengths, but we haven't found all the angles. To find this last angle, we need to use our 180 trick. So 180 minus the other two angles will give me this missing angle in here. If you do that in your calculator and try and practice on your own, you should get that it's 32 degrees. That's called solving the triangle. You found all sides and all angles. Our last thing here, we've got a word problem. Whenever you're given a word problem, my suggestion is that you read it once and then try to read it again and try to draw it out. We're in trigonometry, so every single word problem, we're probably going to end up drawing a triangle of some sort. So if you need to rely on that, sometimes that works out for you. But we're going to read this problem. So it says, Freddie is flying a kite with his little brother. If he releases 12 meters of string at an angle of 23 degrees, how high is the kite? Well, I'm going to draw this out. Okay, I've read it once, now I'm going to read it again, and I'm going to draw it. So Freddie is flying a kite with his little brother. All right, well, let's draw Freddie and his little brother. And he's got a little hat on. His little hat shows that he's Freddie. And then he's got his little brother with him. And his little brother doesn't wear a hat, his little brother. These guys are flying the kite. So they've got a kite on a string. It goes out. And it's a nice diamond kite, yeah. Really nice kite. And the question asks us, how high is the kite? So, when we do this thing, we are going to realize that to figure out how high the kite is, we need to label out things. We're trying to figure out this distance right here. Any distance I'm trying to find, I call it x. Because that would be the height. From the kite all the way to the ground is the height. Now I said, every question that we do in trig is going to be some sort of triangle. Our triangle is from right here across to here. So technically we're going to be figuring out the height without Freddie's height, but that's okay. We're still going to be figuring out how high the kite is. We're going to pretend that Freddie's actually holding the kite all the way on the ground. We need to label this triangle somehow. We need to put in some angles, some side lengths. So far all we have is x is our height. That's all we have. It says in the question, if he releases 12 meters of string, that means this string is 12 meters long. At an angle of 23 degrees. So at an angle of 23 degrees. How high up is the kite? You'll notice now we have a side and an angle. Anytime we're given a side and an angle, we can find another side. To do that, we label our triangle. We have hypotenuse, opposite, and adjacent. We then circle what we want and circle what we got. And we use SOHCAHTOA as a checklist to figure out which ratio we need to use. The first three letters always get 3 checks. Whatever you've circled, get the next check. So hypotenuse and opposite get their checks, meaning so has 3 checks. So we can use sine of theta equals opposite over hypotenuse. The sine of theta, so sine of 23, equals opposite, which is x, divided by 12, which is my hypotenuse. My last step here is to multiply both sides by 12. Because x was on the top, and if x is on the top, then we multiply. 12 times sine of 23 equals x. We punch that in our calculator. 12 times sine of 23, and you find that the height of the kite is x equals 4.7 meters in the air. If you didn't put m for meters, that's okay. As long as you know that the height of that kite was 4.7 in the air. Okay, you should be able to spend lots of time practicing your practice booklet now. Enjoy the rest of class.